Okay, I'll start recording. So I want to, oh, I'm not. So I want to start by giving you kind of the last piece of information that you need in order to do everything in the assignment in principle in the project. And that is using Valgrind. So this is so that's the name. So Valgrind, if you're on Mac, I think it just doesn't. Oh, what about now? Like it's projecting over here. Okay. So if you're on Mac, it doesn't work. So you would need to you would need to connect remotely to what you call it, to ECF in order to use Valgrind, or you can connect in person by going to the office, I suppose, to the lab, I suppose. On Windows, if you install WSL, then you can do Valgrind. If not, then I believe not. But you can, but you can connect to ECF remotely, like we made you do in the lab. So hopefully that will work. Another option is until the end of tomorrow, Valgrind is going to be available as a project that you can submit to on Gradescope. So you can just submit whatever you have, and it'll run Valgrind for you and give you the output. The only problem is it takes 30 seconds. So it's kind of like when you submit to Gradescope, it takes some time. So I made it so it worked. It's kind of nice that it does, and it will automatically run Valgrind on whatever you submit and see for the project as well. But it's kind of annoying, and I think it's like such a barrier to using it that people probably don't use it very often. Anyway, so that's a little bit putting the cart before the horse, because I didn't tell you what Valgrind is. So pronounced Valgrind, not Valgrind, and as some people try to pronounce it. Valgrind is some kind of like a Norse mythology, some kind of gates of the underworld or something like that is what it means. I think it's supposed to also be a pun in the sense that it really does grind through the values of your program or something. But anyway, that's etymology. So what it does basically is detect incorrect accesses to memory and detects memory leaks, not always, but usually. The way it does it is I give it a program, and it basically runs it through line by line the way the Python interpreter would run a Python program. And then it keeps track, if I allocated memory, how much did I allocate and where? If I'm trying to access memory, am I trying to access memory that I'm actually allowed to access? And if not, it just throws an error. So basically it does kind of like something that's like Python on top of a C program. For that reason, it's quite slow. So like you might ask, like, why not just run this always when I'm running programs? That would be convenient. Yes, it would, except it would be slow. Also, it doesn't actually work on Mac and Windows, so that creates problems as well. Okay. So we're here. So in the lab, you'll practice it as well, but I'll show you some code here. So here's how it's supposed to work. So I'll say include whatever, stdio, and I'll include stdlib. So that's for malloc and stuff. And then I'll say B, and I'll allocate like a lot, like 10,000, and then I'll try to print something that's outside of what I'm allowed to. So here I'm allowed to access 10,000 characters starting from P. And I'll say I want the 50,000, right? So I'll say it's a character, and it's going to be the character at 50,000. So that I'm not allowed to do. So first of all, if I run it, what's going to happen? Well, multiple things can happen, and it's not guaranteed that you'll get the same thing every time. One of the options that they did not account for, actually, I need to open the folder. So this is it's just compiling something else I wrote that's not in the folder that it did not open. So file, open folder, and I specify W5 here. Do not save. So now what I have open is just the folder W5, which just have A.C, has A.C. So that should be okay. Abort. I did not say print. So okay. So printf. And now that compiled, and what happened is it just said value nothing. As it turned out, it did not crash. I can try to make it crash. So probably if I try like 500,000, that would crash it. Again, it depends. Yeah, so here it finally crashed. And it says segmentation fault. So if you haven't seen segmentation faults, I promise you that, well, you've been missing out, but not for long. When you're going to be doing project one, and that's going to be all over the place. So a segmentation fault means that the program crashed, and the reason it crashed is it tried to access an area of memory that it wasn't supposed to access. So this is kind of a very simple example of that. It's trying to access, I'll say like P plus whatever, 500,000. So P is some address, P is plus 500,000 is also some address. It's just not a valid address, right? So remember, this is just, and maybe it's more intuitive to say this block is 10,000. It's trying to access element number 500,000. So that doesn't make sense. Sometimes it could make sense, and that could be even worse, right? So it could be that you have P and then you have 50 more of those, and they are all in sequence, and you're accessing P at 500,000, and you happen to get something that works just by accident because it happened that malloc gave you a bunch of areas of memory that are stored in about the same place. And you get some value that you think is valid, you don't crash, but it's not actually valid. So arguably that's even worse because the program is going to keep running at least for a while until it really crashes because the data that it uses are nonsense, but you won't even know. So arguably it's better to find out earlier. So what I was saying before is this is the same as P plus 500,000 dereferenced, right? So this is literally just syntactic sugar for this. And that's what they mean that I'm accessing an address that I'm not allowed to. Specifically, I'm trying to access this address. Is it 500? Yeah, I'm trying to access this address, and this is not a valid address. And that's what the segmentation fault is. So segmentation refers to the memory being segmented into segments, well, parts. And segmentation fault is trying to access a segment of the memory that you're not allowed to. So that's why it's called segmentation. Okay. So all right. So what's another way of getting a segmentation fault just while we're at it? So comment it out. So I could try to say printf, and I'll just say S. And I'll say P. Is this good? Anyone, like, why might this be a problem in terms of what I'm trying to do? Anyone? So it's not this, yeah. No, I'm supposed to print a pointer as a string, right? So it's a pointer to car. What the C string is a pointer to car. So no, that's actually fine. Yes.
Don't start putting in the memory until they just the null characters or don't have a null character.
That's right. That's right. Yeah. So what I'm doing is basically fine if P were actually a valid string where you have some characters and no characters, and then you have a null. But P is just garbage. It doesn't have anything in particular. Now, I did say malloc 10,000, so I would have to be very unlucky in order for one of those to not be null. But that's the situation. So let's try to run it. Okay, I need to move the zoom thing. And there we are. I got pretty lucky. Malloc basically returned seemingly just an empty string, so a string that started with null. So that's kind of okay. But that's just luck, right? So in principle, it could be anything. So let me try and go to P plus, let me say 10,000. Again, I can't even prep this properly because I don't know what it's going to be. You restart your computer and it's going to be a completely different thing. So we'll start at 10,000 minus 3, right? So this is legal if assuming that the contents of P are right? Because I'm saying go to the address P up to the end is -1, and then I say go back to, yes.
Why isn't that in brackets with the star before
it? Because so here I'm printing a single character, right? Here I'm printing a string. So I'm saying start printing from this address and go look for the null because I want to, like you suggested over there, I wanted to get to a situation where I'm not finding the null. So let's see. Oh, I didn't save. Okay, now I save. And that seems to be fine as well. Sometimes it happens. You can, by the way, make it like intentional. So if you say cialloc, technically it will fill everything out up with zeros anyways. So that's an option. But here, in principle, if P at 999.7 is not null, and P at 998 is not null, then we'll try to access and so on. So eventually accessing memory it's not supposed to. So, okay, so we didn't manage to force an error here, which doesn't always happen. So let's do one more that actually I get. So this is one of the exercises. And that's a common kind of thing to wonder about. So here's what I'm going to do. So I'm going to declare a pointer to a pointer to int. Like so. And then what I'm going to do is I'm going to say, okay, I want to allocate that, right? So how do I allocate it? I'll say ppint is this. I just want 1. Right? So, okay, so the variable is of type address of a value that happens to be an address of an integer. And I'm saying allocate that. So the type is in star star. And I'm saying, okay, allocate space for 1 pointer. Right. So, okay. So we have a block of int stars. So then I can say, okay, so what's the actual pointer? Well, it's star ppint. right? So I'm saying, okay, this is a block of int stars. So I want the first int star, I'm going to store it in pint. So the first int star in this block, ppint, is star ppint. Or you could say it's ppint at 0. Those are the same, right? Because so I'm saying ppint, you can think of it. So I'm careful not to say array here, right? Because it's a block, it's not exactly an array, but you can think of it as an array. And I'm saying it's an array of int stars, a block of int stars. So what's the first element? Well, it's this. What is the type of the first element? Well, it's a block of int stars, so the type of the first element is int star. Another way of thinking about it is this is always just this, just gets converted. Right? So go to address ppint and get the value there is this instruction as well. Does that make sense? Questions? And I wrote it like this a little bit on purpose because now I'm going to try to do something that doesn't make sense. I'm going to say, okay, what's at pint? That's the same as saying pint at 0 or start pint or something like that. Why is this a problem? Yeah. That's right. Exactly. So this is completely fine. So I have my block of int stars. So to draw a picture, I have my block of int stars, and this looks like this. So address 1, and I have address, well, here I just have address 1 because I said 1 times size of it. And this is stored at address ppint. Is that making sense? So then I can say star ppint. What is that? This is address 1. Right? So I have a block of addresses, in this case of size 1. Let's make it of size 2, just so that it's maybe more intuitive. So right. And then I'm saying, okay, so what's ppint? Well, ppint is this address 1, a value that's of type int star. Does that make sense? Question? Okay. Who wants more of an explanation? Many people. Okay, so I'm saying I want an array of values. So forget the fact that it's a block, not an array. I want an array of values. Specifically, I want 2 values, and I'm allocating enough space to store 2 values that are of type int star. Make sense? And then I'm saying the address of the first element of the block is going to be ppint. So in this block, or in this array is not quite right, but whatever, we are storing address 1 and then address 2. That's what we're doing. It so happens that those addresses are of type int star. They are addresses of integers, but they're just numbers. So if I say star ppint, what I'll get is this, because this block, address 1, address 2, starts at address ppint. Does that make sense? Questions? Who's not fine with this yet? With just what I said. All right, I bullied you into not saying that. Okay, so all right, so far that's where we are. So now we're saying, okay, star p-int is star p-int. So we're saying basically put star p-int into the variable p-int. So now p-int contains address 1. Yes.
But since star p-int, which is malloc, it's just a bunch of nonsense.
That's correct.
So address 1 curly is nonsense.
That's correct. And that's the problem, is that that's exactly right. So when we try to say star p-int, we're trying to access a nonsense address. And that's why it will crash. Make sense? So when we said malloc 2 times size of in star, what we said is give me a block of memory. We didn't say what to store in that memory, just said give me a block of memory. And then it gives you this block of memory, and it contains some garbage which you interpret as address 1, address 2, but those are just nonsense values. They don't contain anything in particular. Yes.
I guess we covered this, what I said before. There's an image that you have in your head and you kind of keep track of, like star, in star, field star. When you're thinking about it yourself.
Okay.
Are you, like,
So I'm thinking about it the way I'm telling you, which is, and in fact, like there's not. So here are 2 things. So in principle, you could just think about it in terms of like dimensional analysis in physics, just matching types. And that's, I think, what you're referring to, right? So like if the right-hand side is, so for example, here, whatever, like the right-hand side is of type in star, then sorry, that was the left. Then the right-hand side would also be of type in star, and 1 star cancels out one of the stars on line 23. Right. Yeah. Sorry. So that was like the first part of what I said, is like this, and this only goes so far. The other thing, no, like you just have to say, you know, what's it, so I'm trying to access the address. What is this the address of? Like that's the way I'm thinking. And then the answer here is, well, it's not actually an address of anything. Right. So, and that's how I'm thinking about. So I guess kind of to summarize, anytime I have star something, you got to say, okay, I'm accessing an address. What's this an address of? So that's how I would think about it. Yeah.
When you assign the address star p-int to star p-int, doesn't that give p-int an address so that when you assign my-int?
No, so p-int is an address, but it's just a garbage address, right? So like minus 12.5 St. George Street. Right? So just because you wrote down minus 12.5 St. George Street doesn't mean that you get to go to the building that's located there. Well, like it's like a Harry Potter thing, I guess. But so in general, like if it's an address that doesn't exist, you can't go there. But you can copy it, no problem. Does that make sense? So, all right. So the reason this is a problem is when you're trying to say star p-int, so you're going to this address. This address is a garbage address, minus 12.5 St. George. This is when you crash. So let's try and see what's going to happen.
We just did a malloc and just a bunch of.
Yeah, because we didn't say what it is. So any uninitialized value, it's could be anything. Yeah, so we're trying to access an address that potentially doesn't exist. And here again, we got our segmentation code. Does that make sense? Yeah.
You said int my int equals p int.
Yeah. Well, that would be a different problem. So if you say this, then it'll just say that the types do not match, because on the right-hand side, you have an int star, and on the left-hand side, you have an int. So that would just be a compilation error. So the compiler will catch this kind of error from you, but it will not catch this type of error from you. It's up to you when you're trying to access an address to say that it's actually there. Except that Valgrind can help you with it. So on Linux, if you connect to ECF as well, so here the name of the program is A. You can specify, if you remember, with -O, you can specify the name of the program. Yes. No, calloc would not fix this error because 0 is also not a valid address. Right? So it has to be an actual address of an actual thing. But that's a good point. So let's actually try to first run it with calloc. So you have to specify that. So here you have to specify what you want to store there, right? So I'm saying I want all zeros and I want this size. And you still get the problem because it still wasn't a valid address anyway. So, okay. But we'll move back to malloc. So the 0 with 4, so calloc just says like what you want to fill this thing with. So I said 0, and then how many zeros? I said how many zeros. So, okay. So here VS Code automatically just puts a program named A, assuming that I compiled and ran. So one thing to be careful about is that this program A is the last thing that actually compiled. So if you have a compilation error, the program will still exist, assuming you compiled before, but it would be the old one. So that causes problems sometimes. So one way to make sure that that's not the case is to just compile from scratch again and see that there is definitely no errors. So I'll just say gcc a.c. And I'll say -O. So here I say A. Given that we're about to use Valgrind, this is definitely okay. On Windows, you have to specify .exe because if not, it's not .exe. It just won't run, even if it works. Okay, it didn't give me any problems. So A is new program. So I can now run Valgrind. What? Oh, yeah. So I needed the /. So Valgrind is going to give you sometimes stuff that you don't want. Sometimes it's going to be useful. So here, wait, do I have? Yeah. So here what's going on is it's complaining about this guy, right? So it's saying in main, and here you sometimes have to kind of interpret what's possibly going on. So it says conditional jump or move depends on uninitialized value. And it has something to do with strings. Sometimes that's the best you can do. So why is it happening? Well, it's happening, actually, so it's happening because I have this printf here that has to do with strings. And unconditional jump means there is conditional jump means an if statement, basically. And what's happening is when it's trying to print the string p plus 10,000 minus 3, what it's doing is it's trying to print the first character, second character, third character, and then every time it checks, is it a null, is it a null, is it a null? So inside of printf, there is an if statement that says, is this character a null? And if it is, then stop. However, this if statement depends, like Valgrind is saying, on an uninitialized value, because none of this supposed alleged string is actually initialized. Right? So here it says, okay, like it didn't crash, but there was an if statement where inside the if statement was a comparison of something that might or might not be null, depending on how lucky you get. If you run it on a different computer, it might work out differently. So that's what this warning means. Here it says just straightforwardly invalid read. And it would seem that the address was 0. So it would seem that when we said star pnt was 0, and it says address 0 is not a valid address. All right. So we can check this directly. So I'll print pint, and that might be different on your computer. And that addresses a question from before. Can you access pint? Yes, no problem. Like that's not the problem. It will print, and it will probably print 0 again. Indeed, it did. So we can try to run it again. Sorry, I didn't say O. So // is necessary on Linux here. This is just A in the current directory. And over here, so I'm just looking for the output here. So here we again get the conditional jumps. And here we're again reading 0. I think there should be, I guess it didn't print this time. So the printing is unfortunately not guaranteed. Oh yeah, there it is. So here pint is indeed 0. And here it's complaining that accessing that is not allowed. Make sense? Questions about this? Yeah.
For the first, like, conditional jump.
Yeah.
Is that because you're trying to access address that's not valid, or is it because?
So it is a valid address. It's an uninitialized value, right? So what's happening is I have some garbage string somewhere, and I told printf to print it, but it's garbage string. This could be anything. And different runs of the program would produce different values because it never initialized it. So what printf does is it says, is it a null? If it is, I'm going to stop. It's not, okay. Is it a null? If it is, I'm going to stop. But it's not. So go on. But Valgrind knows that you didn't initialize this, that it's a garbage string that could be anything. So it warns you that it turned out, so it seems fine, like you're allowed to access this memory. It's just that you're going to be doing different things depending on what's in the memory, because you're asking, is it a null? Is it not a null? And it could be a null next time. It's just that this time it wasn't. Yeah. Yeah, so I wrote -G because before I didn't, and that did not produce the line numbers. So now I have my line numbers here. Yeah, thanks for asking explicitly. So yeah, so you should write -G so that you get the line number. So here it says like on line 10 when I was printfing that happened. Yes.
The other thing is the fact that it's not initialized because of knowledge that the position initialized.
Yes, so that error would go away if I said calloc. Right? So if I say calloc, and here it would be, I guess, 0. Right, not happy about something. Oh, that's just, this guy. Okay. So okay, so 0, and they want size of car times 10,000. And I save. So this is just a note. This is fine. This is it's just that like this is the compiler actually being helpful and giving me a warning, but the warning is fine. So I'll do this. And that, wait, is it 10,000? This should be, so this should be fine. And so unless I'm not seeing something, I think this is actually fine. So Valgrind sometimes will mess up. In this case, I believe it did. So another thing I wanted to show you with Valgrind is detection of memory leaks. So I'll remove the stuff that was causing problems. So all I have now is I'm allocating a block of 10,000 and I'm never freeing it. So I'll compile that. That is fine. Yes.
When you're on line 8, you're saying we call palette, you're setting the size parameter to 0. Won't palette again.
It's not the size is the second. Oh, that's right. Yeah, thank you. Okay, so it was me messing up. Thank you. So, okay, so now we're fine. And now so I'll explain this in a second. I have the time, but first I'll just run A like this. And what it'll say is that there is a memory, so it doesn't complain about anything except that there are 10,000 bytes lost. So this is a memory leak, right? So I allocated 10,000 characters and I never freed them. So Valgrind says that's a problem. So if I do free it and I run this again, then this is what you hope will happen is Valgrind does not complain about anything, such as 0 errors. Everything that you allocated has gone away. Sorry, so Kai pointed out that I was using calloc not quite correctly. So what you want is you want to say this is all initialized to 0, and then I want 10,000 elements that are of size of car before, yeah.
The dog, there should have to be size of part
Oh, okay, I do. Oh, okay, so it's like 10,000 0. Yeah, I never use it. So yeah, so okay, so 10,000 zeros, and then thank you, and then I still need to say this is the area of memory. So this 10,000 presumably is about, if it were 1,000, it would be zeros spaced out by 1,000. Okay, so this many zeros in this much space. And now this would be a problem either way. This would now not create problems because I already initialized things to 0. So let me run it. Oh, it would because I freed. That's actually another good example. So I'll compile. It's fine. And I run Valgrind, and it's not complaining about anything except that there are still reachable bytes over there. Sometimes it will say that there is, oh, actually it is complaining about something. Wait, is that from before? I think that's from before. No, okay, so this is all fine. A region of size 0. No, sorry. This should be like this. That makes more sense. So I'll compile it again. And this is a segmentation fault. So 10,000. Oh, because no, this is 10,000. This is 10,000. This should be fine. And I don't have a p end. Oh, because sorry. So this is fine. And then sorry, A out was just wrong. And now I do Valgrind 8. And it's all fine. All right, so 10,000 elements of size of car. And they're all 0. And now I'm trying to print P whatever, 998. 997, and it's 0 right away, and we stop, and it's always 0, so there's no conditional jump that depends on an uninitialized value. So another problem that I almost introduced by accident was freeing and then trying to print stuff from the block. Not allowed to do that. If I run this, it would probably work, although it's not guaranteed to work. Yeah, so it didn't crash. But it could potentially crash because I'm accessing this value at P plus 10,000 minus 3, which I'm not allowed to access anymore. I just freed the block P. So I'll compile like this. So you should compile with minus G so that you get line numbers when you run Valgrind. And now I'll run the program 8. And here it did catch an error on line 8. Sorry, this was calloced on line 8, and it says that on line 12, you're trying to access something that was freed. All right. So again, I actually figured out it was like kind of annoying, but I figured out how to make it so that Greatscope runs Valgrind on its server and then gives you the output. So it should work now. However, you know, what happens is you upload to Greatscope, then it does its thing, and then 30 seconds later, you get your output. So I feel like that's kind of too much of a barrier to actually continues to use Valgrind as when you're debugging, which you sometimes want. Like you want to like change something and then check it right away and not wait for 30 seconds because that's too annoying. So if you can set up a workflow that's like this, I think on your laptop, it would usually involve either installing WSL on Windows or connecting remotely to ECF for Mac. I think that's the only option. Then that might be better, recognizing that the remote connection is also not perfect. So there is a trade-off. All right, that's all I have. I will see everyone on Thursday. Thank you.